Welcome to Module 10, Leadership, Teams, and Knowledge Transfer. In this module, we move from solving individual technical problems to building a team that can perform safely and consistently. A BAS manager does not create value by being the only hero in the building. The goal is to create standards, backup coverage, mentoring, documentation, and a learning culture so the organization can operate even when one expert is unavailable. The manager's work changes. A strong technician restores equipment, a strong engineer solves complex systems problems, a strong manager builds an environment where many people can perform safe and reliable work. That means setting priorities, building standards, delegating correctly, developing people, coordinating across facilities, IT, cybersecurity, engineering, operations, and vendors, and removing barriers that prevent good work. In this module, learners will define core leadership responsibilities, assign work based on competence and risk, develop capability through mentoring and deliberate practice, reduce dependence on a single expert, manage vendors and cross-functional conflict, and build a learning culture after incidents and projects. These are the behaviors that make a BAS program mature. A BAS leadership system has 7 core responsibilities: set direction, establish clarity, develop capability, protect the team, hold accountability, connect the organization, build the future. Notice that none of these is simply be the best troubleshooter. Technical credibility matters, but leadership is about making good work repeatable through people and systems. A large BAS program may include a BAS manager, controls engineers, BAS technicians, an OT or network specialist, commissioning support, and vendors. A smaller program may combine several roles in one person. That is acceptable only if responsibilities are explicit. For each critical system, ask who is primary, who is backup, where are the tools, where are the procedures, and what happens if the primary person is unavailable. Work should not be assigned only to whoever is available. Consider safety, criticality, competence, workload, fatigue, development opportunity, peer review, backup coverage, conflicts, time, and access. High-risk changes may require a lead person, independent review, and an operations representative. Lower-risk work is a good place to develop newer staff under supervision. Directing tells someone what to do. Mentoring develops the ability to decide. A mentor asks questions. What is the required operating state? What evidence supports your theory? What else could create this symptom? What is the safest test? What happens if the change is wrong? How will you validate the result? What should be documented afterward? The goal is not to withhold help. The goal is to make reasoning visible. Knowledge transfer is not a one-time class. It is a flywheel. First, a person observes, then they practice under supervision, then they demonstrate independent capability. Then the team documents the procedure, and finally the person teaches someone else. This cycle converts private knowledge into organizational capability. That is how a BAS program reduces dependence on a single expert. Meetings should support work, not replace work. Operational meetings should produce decisions, owners, dates, and clear escalation. A meeting that ends with general discussion, but no owner has not truly converted risk into action. This is especially important in BAS because unresolved issues can sit quietly until weather, occupancy, equipment failure, or cybersecurity pressure exposes them. Facilities, IT, cybersecurity, engineering, operations, projects, energy teams, and vendors often have different priorities. The BAS manager should not frame the problem as one department against another. Instead, use a shared objective. How do we achieve a secure, reliable, supportable, and operationally acceptable result? Then define facts, requirements, risks, options, decision authority, and verification. Vendor relationships should be collaborative but controlled. Define scope and deliverables, establish standards before work begins, confirm access and security requirements, review competence, track schedule and quality, require training and documentation, and preserve owner access to tools, licenses, databases, and source files. The lowest bid may not be the lowest lifecycle cost if it increases dependency, weakens documentation, or creates support risk. A no-blame culture is not a no-accountability culture. It means staff can report errors, uncertainty, and near misses without automatic punishment. The distinction matters. Human error is different from at-risk behavior encouraged by weak systems, and both are different from reckless disregard of known risk. Incident review should ask how design, process, workload, tools, training, and communication influence the event. When decisions compete, use an explicit decision order. Start with safety, then compliance, critical operations, reliability, and cybersecurity, people and workload, lifecycle value, energy and efficiency, and finally schedule and cost. The exact order may vary by context, but it forces the team to make trade-offs visible instead of allowing schedule or convenience to silently become the highest priority. The practical assignment is a team capability plan. Choose one critical BAS system. Identify the primary and backup resources, documentation, tools, vendor dependencies, and recovery skills required. Then create a 90-day cross-training plan that includes observation, supervised practice, independent demonstration, and a documented procedure. The goal is simple. The team should continue to perform safely when any individual is unavailable.